Hey fellers, Brad the Guitologist here, and there's another dude back there, and his name is Scott. And I don't know which video is going to come out first, either this one or the previous one, but probably this one, because this one has the best shot of getting fixed today. So Scott, take it away. What do you have? What's wrong with it?
This is a Fender Pro Junior. It won't come
Pro
on.
Junior 3, right?
Yes.
It's okay.
Yeah. And it won't come on.
Won't come on at all.
Yeah.
No power. Okay, so we have a power issue on a Fender Pro Junior 3. So about when was this made?
I have zero idea.
Is it like
I bought it in the shop.
2000 aughts, or is it recent?
Where would it be? Where would it be?
I don't know. We'll figure that part out.
Yeah.
But yeah, the reason Scott is here, if you guys are confused, because you know I'm usually flying solo, but he's going to be in the captain's chair today, manning everything. We kind of had a deal. He was one of the couple of people who helped me move recently, and as part of that deal, I told him he could set in, and I'll let him do the controls, and I'll just kind of tell him what to do on this amplifier. So if that sounds like something you'd be interested in, if you want to watch a complete train wreck, stick around. Let's go ahead and pop the back off the thing, light it down. And as watchers to my channel know by now, I cannot find my cordless drill charger. So you're going to have to do that by hand. We'll just speed it up right now. Man, you're really good with that screwdriver. You're super fast. Did everybody see how fast he is with that screwdriver? Now, we've got a fuse in here. Now we need to check that fuse, and let's see, let's zoom in on it and take a gander. And you see what I see, ladies and gentlemen? Let's see. You didn't plug this in, did you? Okay.
Nope.
Maybe I probably should have asked before I stuck my finger in.
You didn't put this into the wall. Oh.
Yeah. Okay. Alright, guys. That is what you call a burned out fuse. And this is it's a 2 amp. But it burned out for a reason, and we need to try to figure out what that reason is. Alright, Scott, we're about to pop your Variac cherry here. What you want to do is over there on top of the Variac there are some numbers. So dial it up to maybe 10 at first. Don't put your hands in it or anywhere near it. It's energized now, but very low voltage. All right, we're going to put our ground lead to a ground connection, and we're going to measure potentials from various places in the circuit to ground. But we're going to start off with the part of the circuit right after the I'm guessing this is probably the first filter cap, so we'll measure right off that first filter cap. That'll probably be our B+. Right now we're getting 23.8 volts right there, and if we're not sure if that's the first stage, I'm sure it is because it's the one that's closest to the power. We can go down the line and go off the next big capacitor. So that's the next big capacitor, and you want to go off the positive side. And you can always tell the positive side because they have, let's see, hang on. I get something to point here. You can tell the positive side, if you want to get up here and look, you can tell the positive sides of these because they have like this little indentation usually. And then also, they have a black stripe here on the side of them. They have an arrow that points always to the negative. If you measure from this point to any, I could move this to anywhere on the on the chassis, doesn't matter, as long as it's grounded. And we get a 23.8 volts right there as well. Now the more we dial this up on the Variac, there's 23.7. The more those voltages will kind of spread apart. So this one will be much higher than this one, and this one will be probably much higher than this one. Or maybe not much higher, but significantly, usually, because they have a resistor in between them. But this is the voltage that will feed like the plates of the power tubes. But we'll get it up here to about halfway up. We're at 65 volts and we have 0.16 amps. And we're at 9.8 watts of power, which is fine. And actually here in a second, if I were to dial it up just a few more volts on the input, it would probably start making noise. It might even start making noise now. Yeah. At any rate, what we want to do basically now is just kind of prod around and see if we can make it fail at this voltage. Because if it fails at half voltage, it's not going to be anything catastrophic, most likely. But something made this fail. Maybe were you there when it failed?
Yeah.
What was it doing? What happened?
Actually, the first time it failed, it was in the store whenever I was buying it.
Okay.
And I went to the store, saw it, and I was like, I'm gonna have that. And then went and tested it out. It stopped playing.
Yeah.
It shut off again. So I went and told guy at the counter. He said, "Okay, we'll fix it." I said, "Okay, if you fix it, I'll buy it." Unbeknownst to me, it was like something more than just,
Yeah.
a fuse or a, yeah. So,
Did they have time to put a fuse in it? Do you think that's what they did? Was open it up and put a fuse in it?
I think they, yeah, I think so.
Okay, was this
I didn't actually watch them do it.
right?
I came back the next day and I said, if it works, I'll buy it. And
Oh, I see.
yeah.
Was this
That was the first time, and the second time the exact same thing happened. I was playing it, and all of a sudden it just shut off. So.
okay? Was this used at the time you bought it, or was it new? It was used already. Okay, so somebody probably already brought it in with that problem, and they fixed it and put it back on the floor.
Right.
And then,
Right.
Okay, so whatever happened was a known issue, and they probably just popped another fuse in it just to get it out their door. So what we're going to do is we're going to have to pop this board off of here. We know that it will work. But we're going to have to do some work to it. And I'm suspecting there are probably, if this is anything like a lot of other Fender amplifiers from this kind of era, these could be bad capacitors from the factory. That's very common. Also, bad solder joints on these is very common. Another place where these often fail is the solder joints on the tube pins. And we can actually look at those from where we sit. Usually the power tube pins will be the first to fail because they have the most heat associated with them. I don't see any problems, but then again, I'm not able to get a real good look. So, but what we're going to do is dial this variac down. I mean, right now it's actually steadied down. What are we at now? 190 volts. So it looks fairly steady, but I bet you if I started pushing around this board with this chopstick or something, I bet you it would start going haywire and may even pop that fuse. A lot of times problems don't rear their ugly heads until the amp is also heated up, and what happens is the boards are heated up, they expand, so any issue with a bad trace or something like that will start to show itself.
Well, the thing about this one, the last time it happened, it wasn't on for very long. I don't know if that means anything.
You basically flipped it on, and a couple seconds later it died.
About 3 or 4 minutes.
Okay, well that's long enough though to heat up.
Okay.
So,
Right.
especially were you playing in the basement? Okay, if it's in a basement, usually it's cooler in the basement. So by the time you get it heated up from a cold state, the difference between where the board was and then where it ends up, like expansion-wise, can sometimes be a bit drastic. So.
Okay.
So
I shouldn't keep it in the basement.
Well, no, not that. You shouldn't be able to keep anything in the basement, but it's a fault with the amplifier because these boards are just not that reliable. What we're going to do now is shut the variac down. So we'll go ahead and kill that. And I've only dialed it up halfway. We're not even going to bother dialing it up the rest of the way because I know this is a recurring issue. Also, I can tell by these output tubes that they have had a hard life. Usually on these JJs, it's kind of nice because the paint they use on these kind of turns real dull and kind of white but this should have been bright red from the factory. But you can tell that these have had a very long life, and it really is probably time to replace your output tubes also. Okay. If I were you, I would go ahead and pop some new ones in. I've got a pair if you need them. But we should replace those. We'll pull this board out of here. We're also going to replace these capacitors, these 3 here, because these are shit even from the factory, from this era of Fender. And we'll pull the board out and check the underneath side, and we'll inspect it for any solder joint problems. Okay. Okay, so basically what we're doing now is we're just pulling the board, and we're going to flip the board upright so that we can get a better look at the bottom of it.
Do you have to do both these?
You shouldn't have to, no. Actually, that one won't come out anyway. You'd have to... what you might do actually before you start is clip this. So you get your orange handled, there should be some orange handled clippers in there. Yep. Clip that one, don't clip any of the wires. And then you might also do the same. I've got some, we can replace them later. Okay. But that's just going to give you some more slack getting the thing out. Yeah, and also probably clip that one too. It'll just give you a little more slack, more flexibility. Okay, now you should be able to get the board out, but what you want to do is go very slowly, kind of. And these, you want to pay a lot of attention to these ribbons. Those will break on you if you're not careful.
So what's the best way to do this? Just...
well, I don't know. Just any way you can do it, really, without breaking the ribbon cables. And if you do break them, you wouldn't be the first guy to don't. One thing you don't want to do is ever
press on that.
Don't use that for leverage.
Can I use this?
No, don't press on. Don't try not to press on any components. Try to grab the board if you can. It's easier said than done.
Learning that the hard way.
Let's see.
Should I just take those
These
off?
are definitely getting out in your way. Yes. Okay, let's go ahead and remove these. Alright, so that gets those out of the way. Alright. Okay. Now it should come out a little easier. See what I mean by kind of bending these is kind of pulling it out. I was hoping we could do that without taking all the rest apart, but guess not. Oh, okay. That's just an LED. I was thinking that was a, that actually helps quite a bit. I was thinking that was a Joule 6-volt light.
Begs the question, how'd you get this thing in here?
Yeah, no shit. Pretty much just like that, but in reverse. Alright. And I think I might see the problem already.
What's up?
Maybe not. Okay. Well, right away this solder looked a little bit suspect because it looked like I could fit something up underneath it. And I don't think that is the case. Let's get a closer look. The power section is our big suspect. If something's going wrong, it'll usually be over here on the power if it's blowing fuses. And what I might end up having to do is just coming in here and reflowing a bunch of this solder just to make sure I get it, whatever's causing the problem. We're going to replace the big power capacitors anyway, and those output tubes, and it could be one of the output tubes actually. It's possible it's one of the output tubes that as it heats up, then we can get our screw while we're in here too. But as the tube heats up, then it's causing a failure, and that's possible. But I really don't see anything that jumps out at me. The first thing that jumped out at me was those two solders right there. That one on the left in particular. And you can kind of see it just, you know, doesn't look all that well done. I'll reflow all that solder. But yeah, like I said, most of the problems, if there's a power issue, will be over here by the power section. It's not going to be anything way over here in the preamp usually.
Okay.
That would cause that to pop. So I'm going to reflow this some of the solder over here in this area, and then we'll yank out those capacitors and go from there. Okay, I've gone ahead and put the board back in because, and here's the reason, I'm going to change these capacitors from the top of the board, not from the, I'm not going to desolder them from the bottom and do all that mess, and there's a reason for that. Because when you flip these boards up, if you sit there and wiggle on them too much and you wiggle them back and forth, you can end up breaking these ribbons. And if all you're going to do in one of these amps is just change one of these capacitors, the big ones, I recommend just doing it from the top of the board rather than pulling the thing out. Because you really risk breaking these ribbon cables. They're very fragile, and it's not worth it. If you break one of those, you're kind of in a pickle, because you either have to you'll have to replace the ribbon with single wires, which is something a lot of people do anyway. But if the thing isn't broken, why fix something that isn't already broken? I mean, just wait till the thing breaks. If you do this kind of work yourself, just wait till the thing breaks and then fix it. But that's what I'm going to do with these. I'm just going to change them from the top of the board. So we'll just clip them out like this.
So are those just bad for this amp, or are they just bad in general?
When they first came out with this line of amps, the Blues Junior and DeVille and all of those, the capacitors that they were buying at the time, these Illinois capacitors, they just have a reputation for premature failure. But we're going to replace these, and what we need is 450 volt caps. Okay, I'll show you how to do this first one, and then I'll let you do these other two. Okay. Essentially, well, it's a pet peeve of mine to always put the value up so you can actually see it.
Yeah.
So we put it in the up position like this, and what we want to do is kind of just gauge how far we got to go here, and just bend this around this other terminal, because we're going to attach it directly to that terminal. So after we bent that one to kind of get a gauge of where it is, we can kind of do the same with this one too. We just grab onto it, and then if we want, we can even lift it out and just bend from here. But what we're going to do is leave just enough on here so that we can basically make a little circle here. So we want to make a little circle on this end like that, and then over here we want to do the same thing, and we only want to leave enough to make the circle. We don't want too much lead. And again, not every tech is going to do it like this. I mean, a lot of them will tell you do it from the bottom of the board, which if you have good access to the bottom of the board, that's fine. And if it didn't have these ribbon cables, I would agree, that's fine. But in this case, with these ribbon cables, to sit there and try to do this with the thing up in the air and shit, and push it through the board and desolder all that, and plus if you're desoldering on the bottom of the pad, you saw how hard that was when you were doing it. It's not the easiest thing to do necessarily. We want to straighten these little pieces here, so we just crimp down on them to straighten them straight upwards like this.
Yeah.
And then this should just slide down on top of it. Sometimes you have to kind of bend it downward a little bit, so it's, see what I mean? So it's facing downward. That way it just stays in place when you set it up down on there. But after you make your little circles, you just set it down on there, and that's all you have to do. It's already pretty much got a physical connection, just by sliding it down onto it. So then you just get your solder iron, and when you solder, you want to heat up the work first. So you touch the iron to it, and then come in with your solder, and you want to fill up that whole connection. See how I filled up the whole circle? And you want to do the same thing over here. You want to just basically fill that whole circle like a swimming pool. So you fill that up, and that's it.
Cool.
And make sure your positive end is on the positive side. So you've got a little indicator here of what side's positive.
Don't laugh.
No, I'm not gonna laugh at you.
I'll laugh at me. I'll watch this later.
Everybody, I'll laugh in private. I'm not gonna laugh.
Yeah,
I'm not gonna laugh at you, standing here. Okay, so we've put some new Sovtech power tubes in here. I think that may have been the source of the issue, because on the bottom of this board I really didn't see anything that was obviously burned. I didn't see any traces that were broken or anything like that, or any solder joints that were bad, really. I reflowed some solder, but none of it really looked bad. So we've gone ahead and replaced these capacitors, which are a common point of failure on a lot of these Fenders, and I have to say he did a pretty good job on soldering these up here. Not too bad for the kind of is that your first time soldering today, more or less? Okay, well, that's not bad. Not really bad at all. This could have been strained just a little bit less on this lead.
Yeah.
So, but other than that, it's not bad. So let's go ahead and hook up our power stuff again, and get everything sorted, and then we'll plug it back in and see what it does. Alright, finally got all the power crap put back together. Got a new handle on the thing, because the old handle was this busted ass shit that he had on there. We're going to dial it up slowly on the Variac. We'll go up to just a few volts here, and we'll check some voltages. So we got 55 volts right there. I don't know what exactly we have on the input yet, but everything seems to be okay. Up to 79 and holding steady. Okay, you can see the voltage here dropping down, and that's because our new capacitors are forming, and also because our tubes were starting to conduct right then. So when the tubes start to conduct, that draws down the voltage, and you can tell when it's about to come to life when it starts doing that. So we do have noise. Got a dirty pot. Both pots are a bit dirty. Probably should have cleaned those while we were in there, but we can I think we'll still be able to do it from the side here in a minute. Let's go ahead and dial it all the way up and see if we can make it fail. It's amazing how tolerant tube equipment is. I mean, I'm only at 88 volts on the input, and this voltage is way lower than it's supposed to be on the tubes, but they're still conducting and still amplifying the sound. I mean, they'll operate at a wide range. That's another reason tube equipment is kind of, in my mind, superior, because even when conditions are not ideal, you can usually get something out of one. Alright, we're almost all the way up, and as you dial one of these up, you'll notice your voltages get further apart on these different nodes. So right now we're at 262 volts, and that actually was an identical voltage almost to what we had on the first node when we were at very low input voltage, but now we should be further apart. So we have 295, and then down here on this other one it should be way lower even still. It's 209. So, but our highest one, it should be, yeah, right around the 3 with a pair of EL84s. Yeah, 350 volts, maybe 330, somewhere in there. Yep. That's looking perfect.
Awesome.
Yep. So far, I mean,
Yeah.
you might bring it back tomorrow and say it fucking blew up. But for now, it looks all right. This is my famous chopstick method. Basically, what I'm doing is right here is simulating vibrations when you get it out and start working on it, or playing through it. I mean.
Where'd you learn that trick?
I don't know. I don't know. Probably picked it up from my stepdad or something at some point. But yeah, I mean, if something's going to fail, like, or if you're going to have a microphonic tube, so you can hear that through the, that's actually not bad. It's just ever so slightly microphonic, but that shouldn't be an issue. But yeah, that definitely needs to be taken care of. That's a real dirty pot, so we'll clean that pot. And you should probably let this burn in for a little while. Like, you know, you might just leave it on for a little while and kind of watch it, like when you get home or something. 45 minutes to an hour. Just make sure everything's going to be all right before you go jamming around on it too hard.
Okay.
But if it makes it, you know, 45 minutes to an hour without doing anything, without shutting itself off or blowing the fuse or whatever, you should be good to go.
Okay.
So. Yeah, there's a tiny sliver there, but it's not much. Yeah, this shit's... It doesn't help. This can's almost empty. Maybe that's enough. Okay, we got this thing closed back up. But watch this tube right here. Just jam on it loud. Okay, we got this thing back together. Looking at the power tubes, he was playing through it for a second there, and this one was glowing cherry red, and that was off camera. I'm trying to recreate the conditions here, and it's just not doing it now. So whatever it was intermittent. And again, I didn't notice any bad solder joints or anything like that when I was looking at the board, really. To me, it looked okay. But and so maybe it was a case of one of the pins not contacting all the way or something on this. So what I might do is pull this back door back off and do some measurements and just make sure that the bias is okay, and maybe pull these power tubes out, spray the sockets, and make sure they're getting good connection. All right, pop this thing back open. Just going to check some voltages on the tubes, namely on the tube grids. Let's see. Okay, so there is our plate voltage is 327 volts. Screen's 291 on that tube. 291. They should be identical, 327. Alright, pin 2 is our grid on these output tubes, so we'll check pin 2. And we're at negative 9.7 on that one. And this other one's 9.9, which looks about right. I'm hoping that it was tensioning the sockets that did it, but I just don't know. Like I'm guessing maybe one of these might be shorting or something temporarily at times and screwing up the bias. One of these bypass caps. I am getting some trashy kind of. Now granted, I gotta crank it up, but I'm getting some trashiness at the output. Alright, so there's R30, and that's in that bias circuit, and that one's supposed to be 33K, and it's 32.5K, so that one's fine. Alright, so there is R29, and R29, let's see, R29 is supposed to be 15K, and we are at 14.8, basically 15K, so that one's good. Let's look at R28 next, this one right here, this 56K. I don't think that's it. I think it's those two capacitors right there, or one of them. Alright, so there's that other R20, what was it, R28 or whatever, and it is at 55K, so it's fine as well. So yeah, I'm definitely looking at those two guys right there. Here's one of the capacitors that we replaced. You can see those right in there. And this one actually is reading, well, it's climbing up, but it is a resistor basically. So a lot of our bias voltage was being bled off to ground, I believe, by this. And actually, if it was at a higher voltage than just the 2 volts or whatever is being measured by this meter, that leakage would probably be even more pronounced. This one seems okay. It's at least not turning into a resistor, but you can see the difference. This is probably a good cap. Well, I say probably, but at these voltages, the 2 volts or whatever it is, it's a good cap. If you got into higher voltages, maybe that one would be leaky too, but this one definitely. See, immediately it starts turning into a resistor. Now the resistance will keep climbing, but at higher voltages, that's going to be leaking a lot of our bias voltage to ground, and I think that's what was happening. So these new ones that we have in there, it seems so far like everything is okay. Now that might not be the case for very long, but so far it seems alright. At least I'm getting something closer to what the schematic specifies for the bias voltage. And before we were getting 9 volts or so, but now we're getting 9.8, so we're closer. Still not exactly what the schematic calls for, but we're a lot closer.